All right, here we are evaluating a graph and evaluating and graphing a piecewise defined function. And this is taken from your PowerPoint presentation in the content section of Folio. So let me just show you where that is if you're interested in that. So I'm going to share my screen here. And if we go to, here is week 4 videos, 2.4. And at the end of the list of videos, there's a PowerPoint presentation here that you can select. And when you pull that up, it's not going to look like anything important. But what you need to do is download it. So if you scroll down, and let me see here, where is that? Let's see if I can expand it. Here it is. You're going to select download after you expand it. And then when you click on it, you'll see your PowerPoint presentation. And this is examples that you can go through. If you're still not understanding the material and you want more practice, you can go through these examples. So I want to do an example in particular, this one right here. So that's what I have on the board here. And I'll go ahead and take you to that now. All right, so here we have our function defined piecewise. And what's done here is the domain is split in two. So x runs from -4 to 2, including -4, but not 2. And then for the second linear function, the domain is from 2 to 4, including both 2 and 4. So we're going to join these two together to make the complete domain. So you're going to run from -4 and including -4, not including 2 here, but including 2 here, and then up to 4 and including 4, like that. So this is the domain of the function. And if we put that in interval notation, it looks like this. All right. But for purposes of evaluating, we split the domain in 2 pieces. That's why we call it a piecewise defined function. And so we're going to evaluate f at -3. We have to decide, where does -3 lie? Well, it lies in this interval. And so we're going to plug -3 right here for x. -3 minus 1 is -4. And so the answer to f of -3 is -4. Now evaluating 2, I look and I see that x is strictly less than 2, but here x is greater than or equal to 2. So if I'm evaluating at 2, I'm going to pick this function and plug in 2. -2 times 2 is -4. Now plugging in 4, here f of 4, we see that x is less than or equal to 4. So this is the domain that I'm picking, or the piece of the domain that I'm picking. I plug in 4 and I get -2 times 4 is -8. And now f of 5. Notice that 5 is outside of the domain. So I cannot evaluate the function for f of 5. So it's undefined. Here, we're asked to sketch a graph, and you can see I've done that here. I graphed x minus 1 from -4 to 2. And notice I have an open circle there, and that's because it's strictly less than 2, so we don't want to include that point at 2. But this is the linear function x minus 1. You can see it has a slope of 1 and y-intercept of -1 right there. And so this is the linear function. Then from 2 to 4, including 2, so I've got that circled in, colored in here, and here it's colored in as well, because I want to include the endpoints, because you can see if they're equal to x is equal to 2 and x is equal to 4. So I am going to evaluate the function at those points. And this is the function -2x. You can see that if I extend that out, it passes through the origin. But we're only graphing this piece from 2 to 4.
So that's how it looks. Now, the question that says, is F continuous on its domain? It is not. In order to be continuous on the domain, you have to be able to draw the function without lifting your pencil. And as you can see, I'm trying to draw this. And at this, I have to lift it to get to the next piece of the function. So I cannot draw it without lifting my marker, if you will. And so no is the question to whether it's continuous on its domain.